This is the story of three young engineers and a business major who are on a quest to win the fall 2016 ME2110 competition. We are Omar and the Boys, and here is our final project. However a household name, Team Omar and the Boys was unable to complete their ultimate task.
Here is an outline for our presentation. We first start with the introduction, which includes the background, motivation, and needs of the customers. Next is the design process. This includes the concepts of how we wanted to design our machine, the strategy in the competition, the designs that we did, and then we picked our main design. We then discussed our challenges that we faced. Next, we have the competition, which we have the preliminary and our performance in the actual competition results. Finally, we have the reflection and analyze our performance in the competition, what we could do better. And then there's the conclusion. Background. King Arthur is on a quest to achieve the Holy Grail. However, there are many obstacles and enemies in his way. First, there's the Black Knight. In order to defeat him, you must sweep him or move him out of your zone. Next, you must collect shrubbery, which is collecting as many tennis balls into your own home zone. Third, there's putting the holy grenades of Antioch into the beast lair. Finally, King Arthur must find and obtain the Holy Grail. However, King Arthur is running a little short-handed. He has asked his good friend, Dr. Kerfus, to recommend some extra muscle for him. He has called up the dastardly Omar and the Boys. Omar and the Boys will be facing tough competition as a lot of people will be wanting this job. The motivation for this project is to win the 2110 competition, obtain the Holy Grail, and receive an A in a class. The customers for this project are Omar and the Boys and the 2110 staff, as Omar and the Boys receive all the glory from their performance, and the 2110 staff teachings are shown through our results. In order to do this, we must make a high-performing machine, show strong knowledge for the material taught in class. But however, we have to realize the trade-offs in reaching these needs. Sometimes our needs have to be met, other needs are more prioritized, and those needs have to be met before some of the lesser ones. The design process. In order to maximize the little time we were given, we had to use the planning tools. This helped us lay out what we need to get done in the weeks coming up to the competition and helped us plan effectively. Next, we used tools like House of Quality, Function Tree, Specification List, and Morph Chart to understand what we wanted in the machine. We had to realize what parts we wanted to prioritize in the point system, and then we had to achieve how we wanted to get them, and then we had to do what type of designs would be able to meet this. Due to prioritization, certain features could not be included into our machine. This was caused due mostly to the higher prioritization taking place over the lower ones. In order to think about what we needed to conclude in our design the most, we had to come up with this strategy. First, we thought that delivering the holy grenades to Antioch was the most important. Second was obtaining the Holy Grail. Third was collecting the shrubbery. And fourth, defeating the Black Knight as our lowest priority. We thought that the Holy Grail was our biggest priority because it offered the most points and was the most consistent. We didn't have to compete with anybody to get these amount of points. Second was the Holy Grail. The Holy Grail we saw that no one else in the competition was really going for. So we thought, why not? We took the risk and we went for it. It paid off, but it was also tough. Third was collecting shrubbery. Shrubbery was one of the most hardest and most competitive to get. We thought this is our lower priority and didn't spend as much time on it. Finally, the Black Knight. We saw the Black Knight as the lowest our priority because it didn't offer many points and it was extremely hard and difficult to include in all of our concepts. With the help of the Morph Chart, we were able to come up with ideas that we were able to test or see other people to test and then go on to see their successes or failures.
So our first design was the gravity launcher. The three subsystems in the gravity launcher included mousetrap-powered shrub arms, a pneumatic actuator that timed the release of the holy hand grenades, and a rough idea of what the Holy Grail catcher would look like. And here's our next appropriately named design. Shrubs in, grenades out. The shrub arms are supposed to be released when the Drawer sliders are powered by pneumatic actuators in the back. The hand grenades are released by a 3D printed trigger mechanism, and the Holy Grail uses a claw.
Here we have the PVC grenade and fast shrubbery sling. At the top, a pneumatic actuator pushes the drawer slider down, which allows the PVC piping and a little block to allow the balls in. Also, there's a solenoid which causes a release in a string that causes the Holy Grail mechanism to go forward. At the bottom, we have an actuator that pushes off the Black Knight and the two shrubbery arms, which are connected to motors. Here we have the double-armed mousetrap shooter. A solenoid releases, causing the drawer slide to move down. Then, a pneumatic actuator pushes the balls out of the PVC piping, acting as a cannon. Another solenoid releases, causing the shrubbery arms to move and the Holy Grail mechanism to fully move out. Finally, an actuator pushes the Black Knight thing out, which causes sweeping motion into another person's zone. Here we have the blaster catapult. Acting as like a cannon, balls are shot out by a pneumatic actuator and land safely into the zone. Next, we have actuators that push out the shrub arms and then rake them back in. Finally, we have a Black Knight mechanism that pulls it into our own zone, while at the same time, another spring releases out, causing it to get the Holy Grail. With all 5 designs, we were still left pretty unsatisfied. So we decided to go above and beyond and create a 6th design, the Don.
The reason that we went with the Don was that we looked at the evaluation matrix and it scored higher than any of its other competitors.
The Don consists of 4 subassemblies: the Thief, the Enforcer, the Brute, and the Assassin.
Here we can see the Assassin. The Assassin's job is to place the Holy Hand Grenades into the Beast Layer. To start out, 2 actuators push out drawer slides, which extends the platform all the way up into the Beast Layer. From there, all 6 ping pong balls are individually released into the Beast Layer by a 3D printed switch moving in line with the Beast Layer. After 20 seconds, the entire system egresses, earning us double points.
This is the Thief. The Thief's purpose is to retrieve the Holy Grail. As the drawer slides move forward, the Thief slowly springs out. It is by 2 mouse traps, and then 2 at the bottom and then 1 at the top, caused to spring forward. It's very carefully timed. Then a wooden claw extends forward with zip ties on it. It is then able to go forward, and then it retracts out with the Holy Grail.
Here we see the Enforcer. The Enforcer's job is to collect shrubbery. The Enforcer is not directly connected to a power source, but it's indirectly pushed out by pneumatics pushing on the drawer slides, which in turn, the drawer slides push out the Enforcer. The Enforcer is then raked in by motors connected to the back of the Don.
Here is the Brute. The Brute was our way of defeating the Black Knight. How it worked was there was a hinge that caused it to move forward, allowing to pass the Black Knight. As our system egressed out, it would pick up the Black Knight and then move it into the home zone safe away. However, the Brute caused many problems to our subassembly. We thought it was too dangerous because it caused proper time issues with timing and would screw up other systems that we deemed more important. In the preliminary rounds, we did not do as well as we wanted to. One of the biggest problems was not practicing enough. We didn't practice boxing and we didn't practice performing, so we got disqualified and didn't see our machine work properly. One of the things we didn't take into account for was warping. Over time, our machine warped and it caused many problems. However, it's not how hard you get hit, it's about how hard you get hit and keep moving forward. We got the 52 seed, but we were not dismotivated. We wanted to keep on working and keep pushing to get the Holy Grail. We were working around the clock. No sleep, no food. We were hungry, but we were more hungry to win. Time to show the haters wrong.
Our final results included obtaining 4th place in Best in Show and only advancing in the 3rd round in the actual competition. Here's a short clip of our most successful run in the actual competition. In this run, you can see a machine springs forward, collects all the shrubs, deposits some of the balls, and ultimately obtains the Holy Grail.
Analysis. If we had more time, I think we should have spent less time on the Holy Grail and more time on other mechanisms. Another thing that was a problem for us was careless errors. We got one problem where our string got caught something because we didn't check. Also, our subassemblies were too dependent on each other. Both arms relied on each other, so if one got stuck, the other got stuck. Also, our main slider, if the drawers didn't slide out, then two of the machine's mechanisms didn't work.
To wrap everything up, this class was a lot of work, but it was also a lot of fun. It was a very rewarding experience, and we tried hard, and the work that we put in definitely paid off in the end. Thanks for watching. Are there any questions?